Welcome to the best session of the conference by far. And it's not because I'm moderating. It has anything to do with it. I would say that if it wasn't here. The lightning talk session is really interesting because you're going to see a lot of different projects done very quickly, hitting the highlights. It's going to move fast and you'll have a lot of fun. Our first speaker is Lin Xiong from East Carolina. He's going to talk about using LiDAR to assess impacts of dune restoration. So Lin, welcome you up.
Okay, yeah. Good afternoon, everyone. My name is Lin Xiong. So thanks for the introduction. And I'm a postdoctoral researcher in Coastal Studies Institute of East Carolina University. We were just awarded this mini grant, and I'm very excited to share some ideas and progress about this project. So in this project, we're trying to use LiDAR to assess impacts of dune restoration on the coastal resilience in North Carolina. So let's begin with some photos. We know global warming and the sea level rise cause significant erosion of coastal beaches and the dunes around the whole world. The town of Lex Head is among one of them. For example, the left figure shows the beach on the north side of Genetics Pier in July 2018. And we see significant erosion, and we even see the escarpments on the dunes. And the right figure shows a condemned house on Seagull Drive in August 2017, and this house has to be relocated or removed. So we see the significant erosion happening in Lex Head. So the average shoreline erosion rate in Lex Head for the past 70 years was 0.9 meter per year, and with maximum value of 2.5 meter per year. So how do people respond to coastal erosion? There are many ways, right? We can build hard structures such as jetties and seawalls. We can do beach nourishment, like what we are showing in the left figure. And we can even find ecosystem-based adaptations. So at Lex Head, there is also a non-profit organization called Better Beach OBX. In short, it's BBOBX. And they are trying to plant beach grass and placed recycled Christmas trees along the dune line in outbanks for the past several years. So however, there are low measures of effectiveness of these dune stabilization initiatives. To answer these questions, we must quantify how sand is moving from time to time. So in this project, we use a technique called LiDAR. So what is LiDAR? LiDAR is short for light detection and ranging. And here's an animation showing how spaceborne LiDAR works. LiDAR sensor in the satellites can emit very high frequency of laser pulses. Then they reach the Earth surface and bounce back to the satellites. For each pulse, it measures the distance between the Earth surface and the satellites. And then, since we know the position of satellites, we're able to transfer this information or these measurements to topography information. One of the amazing capability of LiDAR is that it can detect multiple returns from vegetated terrain. So as the figure shows, LiDAR can really allow us to see through the forest in terms of the multiple returns. And we can get 3D forest structure as well as ground surface from our LiDAR data. Landsat images cannot do this, and Sentinel image cannot do this either. So at the CSI, we're trying to develop we have developed a coastal laser scanning system for this project. It's a rapid data connection system. Okay, yeah, integrated with RTK GPS receiver on the top, and our TOS, which is what's called Rigo VZ400i, a scan and go lift, and onboard computing designed by our lab. So TOS is also short. TOS is short for terrestrial laser scanning. It's also called ground-based LiDAR. And for this instrument, VZ400i, it can detect up to 15 returns. So for the past 5 years, I also developed a whole framework from data collection, registration, processing to final products. So one of the most important products from TLS is called DEM, Digital Innovation Model. Here are some preliminary results. The red rectangle in this satellite image shows the region of TLS data at Graff Street, Next Health in 2021 and 2022. Figure A and Figure B show the very high resolution, high accuracy DEM of this region. We can see the topography details of the beach and dunes here. If we use the DEM in 2021 minus the DEM in 2021, if we use the DEM in 2022 minus the DEM in 2021, we get a Figure C. It shows the elevation change in sediment in terms of the sand. So blue color means positive change. We get lots of sand in the dune area. Red color means negative change. We lost the sand. So what's next? We are trying to deliver several products in this mini grant project. First, LiDAR point cloud. Second, processing codes that can be shared in GitHub. And third, high resolution DEMs. And fourth, data analysis such as shoreline change, dune volume change. And fifth, some Google Earth Engine apps that we can share with stakeholders and the community to present the result. And sixth, we are going to try to make recommendations in terms of the future dune restoration management. With that, I would like to give thanks to the NCCC grant, Better Beach OBX, Town of Lex Head, and also team members in our cool project for all the support. And feel free to email me and follow the updates through Twitter. Thank you.
I think we probably have time for one quick question if anybody's got something burning. If not, we'll wait till the end and hit Lee up again. No questions? All right. So our next speaker is Douglas Mackenzie from UNC-Chapel Hill. Oh, I'm sorry. I think I changed your gender. Mackenzie Douglas, that's who you are.
Yeah, and I'm here with my friends Natalie and Anna, and we're representing the UNC Field Study in the Outer Banks with CSI, Coastal Studies Institute. And we're going to be talking about our research project from last fall, 2021, which was a temporal analysis of vegetation dynamics and community perceptions of the Buxton Woods. And this is us. And so for those of you who are not familiar, the Buxton Woods is on Cape Hatteras in the Outer Banks, and it's one of the largest contiguous maritime forests on the East Coast. And it actually is of interest to us because in 1988, it was first made like a reservation site, and it was only 152 acres, but now it's grown to be about 1,000 acres. So obviously it's pretty important. And it's very resilient, it's late successional in ecology, and so that allows for socio-ecological services like an underwater aquifer, as well as habitat to unique species and protection to communities. And these were our research questions. We wanted to know what are the uses, values, and perceptions of change in Buxton Woods among North Carolina stakeholders and residents, as well as how the vegetative community structure composition changed from those historical plots that were actually surveyed in 1988 until today.
So I'll be discussing the human dimensions portion. So in the human dimensions, we interviewed around 11 Buxton Woods residents and stakeholders regarding the woods. And beforehand, we drafted up questions to ask each interviewee the same questions. And each interview lasted around an hour. And after we gathered all our interviews, we did a qualitative analysis. And we did this by transcribing the interviews and then coding them using in vivo. And we found 4 broad themes, which were Buxton Woods, community, process of preservation, and memorable quotes. And when we analyzed these 4 themes, we found that residents' values were similar and different. Some of the similarities were involved with disturbances and change, disturbance being such as storms, saltwater intrusion, or overwash. And they were worried that these disturbances would impact the woods, especially causing them change, such as the disruption of canopy or changing the vegetation within. And we will discuss this more in our natural systems. And some of the other values that were different was the accessibility and management of the woods. Accessibility being, some interviews said that they wish the woods were more accessible, that people knew about it more and they were able to walk through, while other ones said, no, this is my escape. I want this to be my woods. I don't want other tourists to come and take what I see as my community. And this also involves with the management of the woods, being they wish they would manage it more, cleaning up the trail so it was more easier to use the trails and such as.
Hi, I'm going to talk to you about the natural systems component of this. So as Mackenzie mentioned, maritime forests are really unique ecosystems, especially Buxton Woods, since it is the largest on the East Coast. They are unique to several species that can only be found there, as well as marking the upper limit for several southern species. And so in a paper done by Pete et al. In 1988, they surveyed, I think, 8 plots, and we surveyed 3 of the ones that they had previously surveyed. So we have plot 0207, plot 0209, and plot 0206. So we named our plots based off the geographic location as well as the environmental locations that they were found in. So plot 0206 was an upland dune. It had the highest elevation of all of them and was found on a pretty steep slope. Plot 0209 was the mid-range between the two, where it was on elevation but not too high, rather than being in a swale like plot 0207, which was inundated with water. And so we examined species by looking at cover and stem, which is both trees and herbaceous and vine species within the plots. We then broke them down at what quantities they were found. So anything that is present on a label on a pie chart was found at greater than 5%. Anything that wasn't was found at less than 5%. And by comparing these, you can see the changes in vegetation from 1988 to 2021. So for our first plot, the upland dune, you can see a loss of flowering dogwood and a really big increase in oak, as well as the presence of American holly. For our swale plot, which was the one most inundated with water, you can see that there was a big increase in swamp dogwood, which makes sense because it is a type of species that really loves water. And for our lowland dune, you can see that there was the most color of any of the plots. There was a big increase in ironwood, as well as an increase in loblolly pine, and a decrease in oak almost completely. Breaking it down by the numbers, you can see that 44 species recorded in 1988, and there was 47 recorded in 2021. 11 species disappeared, while 20 new species were present. You can see here that herbaceous species were the one that increased the most by 8, which was accounted for by a loss in both the trees and vine species by only 4. You can see that there was also no significant difference in the cover change throughout the years, with most of them remaining woody stems, although there was a slight increase in herbs and vines in the lowland dune. And stem count by point, so you can see by plot. So you can see that there was a really big increase in the lowland dune. There was more trees found, as it increased from 42 in 1988 to 85 in 2021. And so we find this interesting because our research project allows further capstones to examine why these processes may be happening, which could be related to climate change, as well as examining such a unique ecosystem that may be impacted by anthropogenic sources.
Okay, we're over time, but yeah, so this is some photos from the current field study. So that's what's really great about the field sites through UNC, is we're creating a continual project. We were the first capstone to research this, and now there's a second, and so they've done now 5 out of the 8 from 1988. So we can't wait to see what they figure out. Okay, thank you, guys.
So if you have questions for Mackenzie, we'll hold them to the end and try to stay on time here, but we'll hit her up then. Our next speaker is Evan Ferguson from Cape Hatteras Secondary School. And once we get set, you can Keep going, Evan. Great.
Okay, that was a perfect lead-in because our school is in Buxton. I am Evan Ferguson from Cape Hatteras Secondary School, and I am the media coordinator there. I am also on the Sea Grant Advisory Board. As you can see, and we've already been over, Cape Hatteras is a barrier island. We're a small community of approximately 5,000 residents, and there are 7 villages. So before Dorian, my students and I, when I was in the classroom, undertook a project called Student Perspectives on Coastal Change. And this was, the school was inundated with floodwaters after Dorian, and we thought that it was important that we sat the students down and get opinions on what happened and kind of let them debrief. So we did a paper survey of the student body and then also had a focus group. I had to present that virtually at the 2019 Coastal Conference because Highway 12 was out because of a nor'easter, and same thing's kind of happening right now. We have weather coming and I don't know if I'm going to be able to get home tomorrow. And then COVID kind of prevented further execution of the project. So we are back in school and things are pretty normal right now. So we decided to take this back up. I'm no longer in the classroom, but I am in the media center and still have access to the students. So we decided to have a climate awareness hashtag contest and selfie campaign. And then we went to Farm Aid, which I'll show you some pictures, and had a picture of the future climate advocacy booth. And then I also, when we came back from that, we had an online survey and small focus group. And the purpose of this is to just create a conversation for the students where they can feel safe and heard. So this was our Picture the Future selfie campaign. I had a hashtag contest. They could win a $25 pizza gift card. So I had some good entries, many very funny entries. The best one that we got and we chose was hashtag C climate change. So we used that in our campaign, and then we printed these large banners and students were able to take selfies in front of them with different sayings. So the one was climate change is, and then they could hold up different wordings, and then the other one was I can make a difference by. So the students really liked getting up there and getting their pictures taken. So we took this on the road and went to the Farm Aid Festival, which was so cool. And I actually had some students from 2019's class who are now in college meet me there. And they participated in this booth. And we worked with the North American Marine Alliance to create this interactive, student-centered booth that was educational to kind of get the point across what is going on the North Carolina coast. We also took a couple middle school students with us. So concert goers were able to take pictures with the same backdrops that the students were and use the same hashtag. And this was just a lot of fun. So when we got back, we surveyed the population. So there are 365 students, grades 6-12. So it's middle and high school students. My email responses were not as good as my paper responses years ago. I only got about 29% of the student body, and 34% of them agreed to participate. Again, I had to give them an incentive. If they took the survey, they got entered to win $10 to the coffee shop. So why does this matter to our students? We've had 2 non-hurricane weather events so far this year that caused school closures. Luckily, we're able to have remote classes now, so we don't have to make those days up. They already moved our Veterans Day presentation, and we have a big event every year. We try to. This Wednesday, they had to move it because of the weather that's coming in this week. So here we go again. It's 3 non-hurricane weather events that have affected us. So 63% of the students have experienced flooding. This was up from 42%, and then they worry about all this. So good thing is Students believe climate change is real. They believe it's a contributing factor to flooding. And this is our new jug handle bridge right there. And so this was interesting. I want to point out real quick. Last time it was the middle schoolers who had this really bleak view of the future. They thought there were only 20 years left. Now the middle schoolers said we have about 50 or more, and then it was the high school, it was flip-flopped. They said 10 to 15, which was really interesting to me. So I want to go back and see why has this change happened? Is it where they're getting their information? We're not really sure. And so these were some of our findings. There was a big push and outcry about rebuilding dunes and keeping people off dunes. And so this is what they were concerned about: the number of tourists and lack of respect for our island, and that we needed to be more clear and forceful about climate change. And then these are just some student quotes and comments. And I'll be happy to talk to anybody after. Thank you.
Thank you, Frank.
All righty, good afternoon, everybody. I'm kind of the outlier up here because while everyone else is talking about science and experiments and research, I'm talking about getting your science story out to people. And why do you want to do that? Well, there's a couple of reasons. One, at a time when science is not thought of very kindly by some people still don't think climate change is happening, you want to fight disinformation. And you want to fight it clearly and explain things to people. You want to teach people. I mean, you got into this to learn things, and once you learn things, you want to tell people about it. So you want to teach people. And finally, be practical. You want to get your research funded. And a lot of policymakers, stakeholders, legislators might not understand much about science. So you want to be able to communicate it clearly. So hopefully I'm going to do this correctly here. No, I'm not. I'm making nice sounds. There we go. Okay. All right. There we go. Very good. Okay. So before we get into all that, it's always, it's mid-afternoon. We've had lunch. We're all kind of tired. So let's do a little bit of laugh here. The saying, the optimist sees the glass half full, the pessimist sees the glass half empty. Boy, I'm just dying on this thing here. The chemist sees the glass completely full, half with liquid, half with air. Okay, it wasn't that funny. All right, fine. Okay, fine. All right, a little bit about me. I am the science producer at PBS North Carolina. I'm the host and producer of Science-C, which is our science show. Before that, and this blows my mind, the past 30 years before that, I was a local news reporter. I'm still amazed it's been that long. But anyway, so again, I used to cover a lot of science stories along with murders and council meetings and everything else. So this is what I have learned through the years, and this is where we get to the fun part of this talk. First off, know your audience. Who are you talking to? Again, this is to be talking to non-scientists is what we're thinking in this talk here. And here's the fun part. 15 seconds or less. Explain what you're doing. Think of it as the elevator talk on steroids. Attention spans are short. People don't want to hear minute-long talks about what you're doing. You get to the basic point. Explain what you're doing, and that's it. The idea is to grab the person, explain what you're doing, they're fascinated by it, and then you want to start a conversation. And that's how you get into explaining your talk. So 15 seconds or less. No jargon. Think about, you're meeting Elon Musk in an elevator. He's just finished buying Twitter. He says, hey, I've got $1 billion left. What are you doing? And you said, well, I'm studying that. His eyes are going to glaze over before he even gets to layer of fat molecules around the cell. I study the cell wall. Okay, what's the cell wall? There, you've started a conversation, but a person can understand cell wall. This is an example I'm going to be using a couple times during this talk. I study seagrass. Wow, okay. Wow, there are 72 species grouped into 4 families. Okay. I study seagrass. They're the only flowering plants that live underwater. Well, that's kind of interesting. What do you mean? Explain more about that. After you explain it, now you want to say why. Every story in my show answers what I call the Whiffam question. What's in it for me? So why do I care about this? Make it real, make it understandable, make it something that, oh, well, that's going to affect me. Your research is important to me. Again, back to the seagrass example. Seagrass is efficient at removing dissolved nutrients and stabilizing sediments that run off the land. Okay. Seagrass protects the water, cleans the water, protects the shoreline. It's where your fish dinner grows up. Well, I can relate to that. Okay, that makes sense. So again, 15 seconds, get to the point, make it understandable, answer the Whiffam question, use analogies and metaphors. Analogy, think of it as a metaphor. If you want to explain climate change, weather is your mood. Climate is your personality. Ah, okay, I can explain that. Back to seagrass again. Seagrass evolved from terrestrial plants that recolonized the ocean. Oh, okay. Seagrass is like the grass on land, but it moved into the ocean 70 million years ago. It needs sunlight to make food. Okay, I know what grass is. I still remember that you need sunlight to have, create photosynthesis and have plants make food. Okay, I can understand that. If you happen to have a prop when you meet Elon Musk in the elevator, that's great. Props rock. People like props. They can look at props. They can hold props. If you don't have a prop, well, then just believe in what you do. Be so good, be so excited about it that people can't not ask you more about it. Be passionate about it. After all, many people, you spent your career, you've at least spent, years and years of study. Be excited about what you're doing. And again, as you're talking to this person, you're having a conversation, you should ask them, do you understand what I mean? Seagrass, it's underwater. Do you understand? People like a conversation. They like to learn things, as long as you're passionate about telling it to people. So again, 15 seconds, no jargon, make it relatable, make it understandable, relate it to people. And again, answer the Whiffam question, what's in it for me? All right, thank you. I'll be glad to, if you have your 15-second elevator talk, I'll be glad to listen to it afterward. Or my email, real quick, is fgraff, Graff, @pbsnc.org if you have any questions. Thank you.
Thank you, Frank. Josh. Our next speaker is Josh Himmelstein from UNC-Chapel Hill.
All right. Hey, everyone. So I'm Josh, and I'll try to apply at least some of the things Frank just talked with us about, though if I'm doing poorly, let me know, Frank. So today I'll be talking about sensing topography-mediated gradients in suspended sediment and the implications of those gradients for North Carolina's marshes. So suspended sediment you can think of as stuff that's just floating in the water, and that's the food for a salt marsh. A lot of these marshes depend on things floating in the water to be deposited on the marsh and build elevation. And we care about salt marshes for a lot of reasons that have been mentioned in talks today, but primarily for their potential to buffer storm impacts from reaching the coastline, or for their nursery habitats for fish. So all these reasons we care about marshes, we need them to exist if we want to continue to have these ecosystem services. So one way they exist is by having this food suspended in the water. And that material gets emplaced and builds elevation and helps compete with sea level rise. So here's a marsh in North Carolina doing that. And we as humans can change the supply of sediment to watersheds in coastal North Carolina and around the world by developing land. And you can see here through time in Oyster Creek, North Carolina, the watershed has been developed. And importantly, silviculture operations and other land development has freed up a bunch of sediment, and that sediment propagates downstream and can infill tidal channels and also salt marshes. And here on this graph, you can see in teal, that color kind of in the middle, that mass accumulation rates or material has increased in deposition as land use has changed. So these higher deposition rates might infill tidal creeks. But at the same time, the marsh interior needs that sediment to face sea level rise. And so while these tidal creeks are infilling, the marsh might not be filling as rapidly. And perhaps there's something dividing those two that's influencing this kind of propagation of sediment into the marsh. And I'm gonna look specifically at the levee, which is this interface between the tidal channel and the marsh itself. And it's kind of this brownish feature you see at the edge of this image here between the tidal channel and the marsh itself. And it's an elevated part of the marsh, a higher topographic feature that might mediate water flow across it. So the hypothesis I wanted to test here, or that I am testing because this is incomplete as is that levee configurations, whether it's their height, their width, or continuity, moderate gradients in total suspended solids. So maybe their size could change how much of that material that's in the water gets propagated into the marsh and helps it survive. But to do that, we realized we're gonna need a bigger batch of sensors. So like in Jaws, they needed a bigger boat. We need more sensors, and we need cheap sensors. Normal sensors are anywhere from $2,000 to $5,000 that can look at suspended solids in the water. And we worked with a lab that has built them for around $200, and we can put these in a lot higher spatial density than is normally capable with these expensive sensors. So these optical backscatter sensors look like this. They're low cost, like I said, and they essentially work on the principle that by emitting light out of a diode there on the left in that square and receiving light back, they can detect how much material is suspended in water. So the more material in water, the higher signal is returned or bounced off that material, and then we can calibrate that in the lab to suspended sediment concentrations. And so it's a pretty simple principle, but is usually quite expensive to access in the field. And so this is, using a sensor like this allows us to quantify these suspended loads at a much lower cost and across many levee situations. So one of those levees, here's a transect from one of these sites where we've installed these sensors. It looks like so. We have a sensor in the channel, one kind of on the outer marsh here that existed at this site, and then on top of that levee, which is that high feature you see around 5 meters in, and then in the marsh interior. And so we wanted to compare suspended sediment concentrations at similar times across all of these sensors. And we also had a water level logger out there to see when the whole platform was inundated. Here you can see water level through the month of October. Anytime it's over that green line, there's a potential for inundation. So now looking at that first sensor in the channel, seeing what that sensor sees, there is kind of a consistent trend in turbidity throughout the whole period of that deployment, kind of low and consistent. Now looking at the outer marsh, we actually begin to see higher suspended sediment concentrations for this duration of the study. And those higher values in the beginning of the month are correlated to higher tidal prism, so greater flooding of the marsh platform, greater suspended sediments. On the marsh levee itself, a very similar story to the outer marsh with higher suspended solids, and on the marsh interior, slightly lower values than on the levee and the outer marsh, perhaps because some of that material has been stripped out or precipitated out as water interacts with vegetation, slows, and drops out that material. So maybe a lower capacity for sedimentation and marsh survival on the marsh interior, where suspended sediment concentrations are lower. Zooming into a single time period, we see a similar trend, and we see decreasing values throughout the tidal flooding as some of that material drops out. Aggregating this into a single figure for the entire month, we see similar trends and also lower values on falling tides as on rising tides, as that water's kind of falling off the marsh. But interestingly, this might not be the trend we would suspect if the channel is the primary source of sediment. And so perhaps we're missing something if there's more material on the outer marsh and levee that's sustaining it than is coming from the channel. And in many cases, we have local erosion. So here in Oyster Creek, North Carolina, when we analyzed shoreline erosion rates, we saw that 10 to 50 centimeters a year of that shoreline was eroding, potentially freeing up sediment that could be in place directly on the levee and viewed by our sensors, really kind of elevating that signal on the levee, but not in the channel. And so we're continuing to do this across a variety of levied sites. Either they're bigger size levees or different configurations, different distance from the edge. And we're using these low-cost sensors to determine how marshes might respond to changes in sediment and what that means for the longevity of marshes with different sea level rise scenarios. So with that, I'd love to entertain any questions if there are any, or I can take it at the end. And I'd love to thank funders, which are Sea Grant and ABNEP, and then all my lab mates and collaborators who helped make this possible. So thank you.
So our next speaker on the program is Lagomasino, and he's not here. So I think it's either my go-to karaoke song or we keep rolling. I would say let's keep rolling. Ryan Mitchell from DRMP is next, and Ryan, welcome to the program.
I will not be singing.
Yeah.
All right, hi everyone. My name's Ryan. I am a civil engineer with DRMP. I focus on water resources projects, but most specifically, I do a lot of restoration projects, and I'm located here in Cary, in the Raleigh area, but I do projects all across the Southeast like this. So the one I'm going to be presenting today is the Titusville Causeway Multi-Trophic Shoreline Stabilization and Resiliency Action Project. I did not name this project, but we did get a lot of grant funding through this, and it helps to have a name that kind of hits a lot of keywords when you're talking to the legislators and the grant agencies. So hence why we get the longer name there. This project is located along the central east coast of Florida, and as you can see here in this map, it's located also directly adjacent to the Merritt Island National Wildlife Refuge, and this wildlife refuge is about 140,000 acres, and it's critical habitat to about 1,500 species of plants and animals. And I think there's about 21 listed species, either with the state or fairly listed for endangerment. So this project is also happens to be what's thought to be the largest horseshoe crab spawning area. And this just the area you see in this picture is there. You go out there anytime, there's a lot of horseshoe crabs out on the shoreline of this project. So we're specifically focusing on the shore, or the causeway itself and the shoreline. You can see here that there's some historical imagery. It's a little hard to see in these smaller pictures, but one of the things you would notice if you zoom in on it is the shoreline has started to recede at several different occasions, but it's not hard to notice that when you drive by it up close and see it after a storm. There is continuous erosion going along the coastal area of this project all the time, just from larger storms, everyday type storms, but certainly when the larger hurricanes and tropical storms come through, there is significant erosion. And you can see in that previous picture, as well as this one, just how close that erosion gets to the roadway there. This is also one of two causeways that lead to the Kennedy Space Center area over there. So it is a critical road that they need to get to work and to do the work that they do over there. And so washing out is definitely a threat for this area. So some of the things that the DOT has tried to do is put some riprap in there to just prevent some of the erosion, but you can see the erosion even laps over that and starts to continue to eat away at the shoreline. Plus it's not very aesthetic for the shoreline area, and also if you can imagine the horseshoe crabs that come to spawn on this beach area, this doesn't serve them very well. So along for the design process, we like I said, we did receive a lot of grant funding through this. We kind of funded this in stages. Brevard County has been the lead agency that's doing this project, but they have not actually had to contribute any money to this project. So we funded it fully through different NGO agencies and grants and from the state as we've kind of gone along. So we've done different stages. We did a 60% design, we did a planning design, we did some community engagement to talk to folks about how we were going to develop this project. And then finally, it's fully funded through construction to the tune of about $4 million. So why is this project important? It's protecting critical infrastructure, restoring it. They have failing seawalls and riprap that are along the shoreline there. It's to also for future protection to prevent against sea level rise and storm surge resiliency. And it's also going to help bridge ecological functions and recreational access to the infrastructure into an infrastructure project. And this area is particularly popular because a lot of people come out to this area to fish, swim, and to watch space shuttle launches, things like that for many decades. So one of the first things we did with this project was we did some wave modeling just to try to understand what the problem was and how we could solve it and what some of our solutions may be. For that wave modeling, we did take into account wind direction, wind speed, wind fetch, that's the just unimpeded distance over water, and our sea level fluctuation. So this is just kind of a quick heat map here to show what that modeling looked like. So basically, we looked at a couple different storms, a couple different configurations of these wave attenuating devices that I'm going to talk about here in a minute. And so for some of these waves, we had 3 to 4 foot waves from a 40 mile per hour storm. It knocked it down to about 1.5 feet. Our waves were reduced by 2.3 feet in that one. And then we have a 75 mile an hour as you're approaching hurricane speeds. And the wave reduction was a little bit less at 2 feet, but those were larger waves. So this is what they look like. These are the wave attenuation devices that are going to go out there. These are like a 3-sided pyramid type of concrete precast structure. These structures are cast onto on the shoreline, and then they're brought out by crane and barge and placed into place. They are relocatable. You can remove them if you want to. It's kind of one of the neat features about them. This is a project here in the Tampa Bay area. And I will note that there's also going to be a similar project to this in North Carolina that the group that I'm working with on this project, they're working in Sugarloaf Island near the port of Morehead City to work on that island and try to get some of the erosion under control that's happening over there. One of the things they found in several of these projects that have been installed is that the sand starts to accrue behind these wave breaks, and so it actually replenishes the shoreline as well as it does protect it. Another thing is that it also provides a lot of habitat for marine life. It's very quick to turn into an underwater reef area, and you see a lot of just biodiversity that pops up in areas that were just kind of more sandy and not as populated. So this is kind of a look at the project here and what it's going to look like. The hatched areas are the sand restoration, where we're going to bring fill in to repair the shoreline. We're just going to kind of try to make a consistent shoreline where a lot of it's been eroded. We're putting these wave breaks about 400 feet offshore. Big reason for that is there's a big trough that's between where these wave breaks are and the shoreline, and that's because that's what they use to excavate to create the causeway. So it's a little deeper there. This is kind of what they look like. This is what one of the arrays look like. Kind of show you where the sea level is and kind of span arrangement of them. This is about a 150-foot section. Overall, it's about 2,000 feet of what we're doing here for the shoreline restoration. This is a 150-foot section, just showing you that some areas are going to have a lot of fill, some areas have not that much fill, but then in other areas won't require any fill at all. This is our upland or our shoreline planting. Just going to go from a roadway clear zone area where we're not going to have any plants to upland planting, transitional, and then an estuarine and sand renourishment area. It's a little representation of what it's going to look like. And here's some of the permits and deliverables we've had for the project. There's been quite a bit of permitting that's gone into this. It was a little more challenging than we expected it to be. There's a lot of attention being paid to the impacts of this, which we're presenting this as a beneficial project, but it's been kind of reviewed as more of for the negative components of it. But we're overcoming a lot of those. We've done a lot of extra studies, a lot of extra work to just give those justifications and assurances that this project is going to be an overall benefit for the area. And last thing I'll say is I do have a poster for this. I'll be at the poster presentation. I'd love to hear about your projects that are maybe similar to this, and I'd be glad to tell you about this project and more. That is all I have.
Our next speaker is Ashley Oliver. Ashley is the Reef Fish Fellow for North Carolina Sea Grant. Thank you, Ashley.
All right, hello everyone. My name is Ashley Oliver. I'm the South Atlantic Reef Fish Extension Communications Fellow with the South Atlantic Sea Grants and the South Atlantic Fishery Management Council. For the next few minutes here, I'm just going to kind of tell you guys a little bit about some of the reef fish issues or some of the issues in the snapper grouper fishery. You also hear me refer to it as reef fish. And then get into kind of the makings of this fellowship, a little bit about this best fishing practice project that I'm working on, and then wrap it all up with what I've really enjoyed and loved in this first year of the fellowship. All right, so jumping on in, for years and years, reef fish have been a really important source economically and socially for those that live and visit the coast each year. However, more and more people are moving to and fishing the coastal waters, but due to that increased fishing pressure, fishery scientists have deemed a lot of the reef fish stocks as overfished and undergoing overfishing. And so there is a lot going on this slide right now, but there's a lot going on in this fishery. The South Atlantic Fishery Management Council currently manages 55 species under a single snapper grouper fishery management plan, and they have to try and manage these as holistically as possible. Diving into a little deeper and why this is such an issue, reef fish live in deeper waters and they often suffer from barotrauma. And this is pressure-related injuries when reeled up quickly from depth. This causes the gases to expand in the body, and they're not able to get back down to the bottom by themselves when they are released in this condition. And if not assisted by a descending device, which is a weighted tool that helps get these fish back down to the bottom safely, they'll often die from these injuries or get eaten by a predator. So to kind of bring this slide and the previous slide together, with more people fishing, there's more interactions with fish that need to be released. And if released improperly, they won't be put back in that population to reproduce for future generations. So therefore, there needs to be some kind of long-term solution to really help rebuild these populations, especially considering that this is such an important source of income for fishermen. Kind of put that in perspective, the American Sport Fishing Association estimated that in just North Carolina, all saltwater fishing made up for about $518 million in wages back in 2021. So that's a lot of money. Sea Grant and the South Atlantic Fishery Management Council have used various outreach strategies in the past, but what they really truly needed was a position that was dedicated to support both organizations. And so with that, they created a Reef Fish Fellowship to educate South Atlantic anglers on the best practices that they can use to help the survivorship of these fish, and also aid in the communications between fishermen, scientists, and fishery managers. And so as of July of 2020, there were a few best practices that were regulated or put into place. And that includes the use of circle hooks and having a descending device on board if you are fishing for snapper grouper in the South Atlantic federal waters. And so a descending device, like the one shown here, it's a weighted tool that helps these fish get back down to the bottom safely. But what I'm going to focus on here is the best or the outreach strategies that we've been using to really kind of push this information out to the public. Starting with these tackle shop visits, I've been traveling around the South Atlantic, going to different tackle shops with partners from Sea Grant and the council, and just talking about the regulated best practices, best handling practices, and some of the council projects, how to serve on an advisory panel, and also how to make public comment. We also wanted another avenue to get this information out, and I see that I'm running out of time, but we wanted another avenue to get this information out. And as we all know, people have a hard time listening to the government. And so what we have learned, and thanks to many different surveys and projects done, it's really effective to work with fishermen and local businesses that are considered respected in the community. And we're also taking offshore trips with media such as writers and influencers, and showing them firsthand those reef fish issues, and hopefully to teach them how anglers can mitigate the barotrauma and increase the survivorship of fish. And so to kind of conclude here, I kind of want to be a little selfish real quick and just kind of share some of the things that I've really loved so far in this fellowship. First being, I've been able to travel and meet so many new mentors and friends, and just learn some hear some amazing stories from the fishing community. And so, when this fellowship is over next December, it's going to give me so many different avenues that I could pursue if I wanted to. And then from kind of a more business aspect, with Sea Grant and the council working together, they are able to leverage their resources, especially since they've got the same goal in mind. And it is a structure that I really hope other programs will consider. And so up here on the screen, I have my email as a QR code if you're interested in reaching out. And also the other QR code is the council's best fishing practice webpage if you guys are interested, and happy to chat afterwards as well. So thank you all.
Before she gets away. So our final speaker, so be thinking about who you've seen and questions you might have. Our final speaker is Nick Corak from Wake Forest University.
Hello, everyone. I'm Nick Corak, and I'm from Wake Forest University. I'm a PhD student in the departments of physics and engineering. Up here, you can see some of my collaborators. And I study vegetation responses to extreme events. And I'm here today to talk to you about vegetation responses to fire. In June of this year, I was awarded a grant from the North Carolina Sea Grant, North Carolina Space Grant, to extend our research areas to the coastal plains of North Carolina and to other coastal regions. And in case I forget, there's a poster session with an undergraduate from our lab, Matthew Barnes, that you can check out this evening. So prescribed fire is not wildfire, and it's a tool used to for a variety of reasons, but mainly for habitat preservation and burn load or fuel load reductions to prevent wildfires. The way we study this is through vegetation phenology, which can be thought of as the vegetation growth stage. We consider several things like the growth cycle, the changing size of a leaf or a plant, and changing color, but we're going to focus today on the size, and we use a measure called the leaf area index, which can be thought of as canopy density. So if you were to take a column of the canopy and smush it down, how many layers would there be? And you can see the little schematic here. If you have 3 layers of vegetative material, then you have an LAI of 3. And it's important to note that fire disrupts phenology. Fire essentially destroys the growth stage. So this is a grassland. It's not a coastal region, but we're able to extend this research now to the coast. And we have a few questions we'd like to answer. One is, how does prescribed fire affect the immediate and long-term vegetation responses and recovery across North Carolina ecosystems? And what are the differences in remotely sensed and ground observations of LAI? And how do those estimates of remotely sensed and ground observations vary across vegetation types and at different times of year, including not just when we're sensing the LAI, but also when the burns occur? And this project is in its preliminary stages, so I'll just showcase what we're doing and some of our early data. The ground observations are collected using a Lightcore 2200C plant canopy analyzer, and it takes in a gap fraction measurement, so it reads how much light is passing through the canopy. We can do this in forested regions and grasslands, and we can also capture the understory, which is the lower growth under the canopy. Most of our study sites we're revisiting at 1 to 3 month intervals, which we're currently looking for any partners who may be closer to our study sites so we could increase the frequency at these revisits. We also use remotely sensed observations of LAI using MODIS, which is a 500-meter spatial resolution, but it does come every 8 days, and so we get a much more frequent temporal resolution, especially in our coastal sites where we're not able to visit but every 3 months. So here's some collection sites. The blue ones are our Piedmont sites, and the green are coastal sites. And this is a little symbol of Wake Forest to kind of get a feel for where we're at. And our grassland that you've seen earlier, and a coastal plain site where we have a longleaf pine savanna and the green swamp preserve. Some things to consider are the changing vegetation as you move from east to west. So you go from more needle leaf and evergreen forests and savannas to more deciduous forests and grasslands. And the soil types and textures are going to change as you move in that direction as well. Our study site that has been with us the longest has seen 2 fires starting in March of 2021 and again in April of 2022. And you can see here two plots of our ground observations of LAI. One is our main field, which is the outlined in the, let's see, does this have a laser? In the upper right corner, and that's where they intentionally burn the field. Fire debris actually jumped over this little burn and caught a little other area on fire, so we're collecting data there too, just for measures. It had never been managed before, so that's in green. And the gray is our MODIS data collection. As we can see here, we, in our ground observations, are picking up more vegetation density for a longer period of time than MODIS. That's mainly because MODIS is a remotely sensed observation, and it's reading infrared and near-infrared color from the color spectrum. So it's going to see brown and then think that there's no vegetation there, when actually there's still a pretty dense canopy available. We have another site that we started in March of this year in Falls Lake, which is just north of here. And I've been there 3 times. I'm actually going to go tomorrow to collect data while I'm here. And you can see some changes in the vegetation as you move through. Sorry, I'm out of time. But you can see here, they're changing vegetation phenology in the understory and our 2 visits to the coastal site. So this is in its preliminary stages. And I'd like to just summarize real quick that we're building these time series. We're the only people currently building time series to follow vegetation responses to fire. And we're looking for partnerships. And we're also looking to explain the differences between the remotely sensed and ground observations based on the types of sensors that are seeing the vegetation, either from the remotely sensed observations or ground observations. And here's a couple of our partners and our funding sources and our lab members who've all been with me in the field, and including Matthew, who you could see in the poster session. So if there's any questions, thank you.
Podium, Nick. Any questions for Nick related to his research?
All right, thank you.
So let's just move to some. That's even better, volunteers. So just general questions for any of the speakers. I have a couple from online for a couple of folks over here, but does anybody in the room have one? I'll give you the first stop. And let me get back there with the mic so that people can hear you first. Thank you.
To Mackenzie's crew, I just had a question for you guys about your survey that you took of people for Buxton Woods Trail. I've worked out there for a bit, and I know you mentioned kind of local thoughts on that reserve. Did you also gather thoughts on tourists or non-locals as well? I'd love to know if there's any differences that you did see or that you would hypothesize seeing between how they view that Woods Reserve.
Okay, here we go. Oh, great question. So for our first survey, since we were the first field study to go into Buxton Woods, we wanted to get a purely local perspective. So we kind of like understand why it mattered. And so now actually what I was going to mention on that last slide is the current field study is looking into specifically resource managers as well as resource users of the Buxton Woods to see how they are kind of feeling about that, I guess, generally. And they're using the 3CM method. So using the interviews we had from last year, they actually found about over 200 terms that came up quite frequently. They whittled that down to about 175 and eventually found 26 themes that were congruent throughout all 11 interviews that we did last year. And now they're going to those users and those resource managers, and they're showing them these 26 terms actually on note cards, and they're having them kind of move them around and rank them so they can have a quantifiable understanding of how they're feeling about the resource management as well as the resources that are available there.
Hi, oh, is it working? Okay, I have a question for Frank. That was an awesome talk on science communication. Do you have any more advice specifically for podcasting, given that it's just your voice and you and putting it out there?
I think a lot of the same things, keep it simple. I think podcasting, my sense is that, and I don't listen to a lot of podcasts, but my sense is that podcasting is a lot more than just, I'm going to stand in front of the mic and turn the switch and talk for 5 minutes. You better have it reasonably well produced. Again, make it interesting. Am I going to sit there for 5 minutes and just hear someone talk? Probably not. Have some music, have some interviews, have a couple of voices to change it up a little bit. Yeah.
Frank, while you still have the mic, another question from online. So is there an example of a response to one of your stories or a series where audience members took positive action?
Yeah, yes, in that you get a lot of emails of that was really interesting. I really enjoyed that. I want to learn more about it. Our show isn't, we're not Nature or Nova. I'm not going to go in depth in something. My idea is if you come away with 4 or 5 facts, I've done my job, and you want to learn more about it, I've really done my job then. So, yeah.
Yeah, let me get you the mic.
I have. I mean, the blessing for me is that an audience on PBS probably is a little more interested in science than a lot of people, which is a good thing. But even still, our stories they're on the air. In the tech world that we live in, our stories are on the air, they're online. You can get them on whatever device you're using, wherever you are, whenever you want them. So YouTube, our website, and we get a lot of traffic, which is a great thing. So I'm assuming there are a lot of people who might be interested in a topic, maybe not science in general. So again, why do I care about this? I think that's the biggest thing facing science in general is, why do I care about this? Climate change. We did a 1-hour special about resilience and climate change, and we called it State of Change, and looked at a lot of different topics, and one of them was beach nourishment. And everybody we talked to, from tourism officials to city council members, they all said, yep, sea level's rising. We don't know how long this beach is going to be here, but for right now, beach nourishment is working, and we're keeping up with it. And hopefully that will give us time to figure out what to do next. Well, that explained climate change and sea level rise and in a way that people can relate to. So I think that's the big thing is you gotta, why do I care about this? You gotta answer that question. Then you can have a bigger conversation. Who's gonna ask the? Oh, you know, I think everybody. I think I think there's a lot of interest in science, good or bad, and you better be ready to answer it from both sides, or for both sides. Yeah.
For Evan, talking about the farm aid experience, you know, so how did your students gain in confidence in sharing their experiences during that day at farm aid? And do you have any examples of that?
How did they gain confidence
Yes.
to be able to? I think that they're living it, and so I took people who I knew were going to talk, and several of them actually were interviewed by Frank in the State of Change article. So they had some experience with that. And we had visuals. I actually have some here of what's happening to Highway 12 and the fisheries. And one student actually owns his own charter boat now. He's barely 20 years old. So they're very outgoing students. And, you know, just being able to talk about it and hash things out in school in a small group, in the focus groups, kind of helps them to get comfortable with it. But they did a great job. I was so proud of them.
Thank you. Anything else from the room?
Okay, with specific reference to that change that you noticed in the perceptions of, I guess, like viability for the future from your students at the secondary school, I understand like Cape Hatteras Secondary School is a pretty small school. Did you notice that maybe, you know, 2019 to 2021 is about a 3-year difference. So some students might have gone from middle school to high school in that time. Did you ever notice that maybe it was a specific culture of perception based on grade level and, you know, the interactions between those students there? Or did you see that it was pretty much kind of like not related to that?
I honestly have not dived deep enough to figure out what happened, but I was shocked that it was completely flip-flopped from 3 years ago. And I think that part of it is, I'm sure COVID, them being home for several years, and then just the reality of what we're seeing on, I mean, it's like monthly. There's something monthly that happens compared to a few years ago. And I also, I didn't keep track of like who in the focus group was actually like from Hatteras versus who moved to Hatteras. So in the middle school group, I would be interested to see what I am thinking in my head is the middle school group. Now, there were a lot of students who had just moved here in the past few years. So they haven't lived it as long. So that may be part of what their understanding is. But yeah, I definitely want to dive deeper into that because it's really interesting.
Other questions? Other volunteers, partnerships, anything we can pull off? Yep. Bring you this.
So Ryan, don't mean to put you on the spot here. Got a little technical question for you, okay? So with the WADs, I've always been curious because, you know, the wave energy, the energy is always concentrated at the top of the water column. WADs, you have the surface area inverted to where most of your surface area is at the bottom. So when you look at the pictures, you can kind of see gaps in between the WADs. When you're modeling the attenuation, you're assuming it's performing at a certain attenuation factor. After a while, when you have settling or storms come in and move the WADs around, I've noticed you'll see those gaps kind of develop a little more. Do you ever see any sort of change in your assumptions on how much attenuation is happening after that movement or that settling occurs, or is it just kind of negligible?
Well, I would say that, a lot of these swings are in the ground, so this isn't like a pilot project. Others have been in there. I think the ones that are more closer to the shoreline, you do see those the graphs are. There is concentration of this group that has been attenuated. But I think one of the things I'm really be interested in this, particularly with that trough where they dredged out a lot of the sediment to the causeway, is I was wondering if the waves get larger as they approach the shore because they go through that deep section. So this is going to interrupt the waves in that cycle when we get in there. And you can, I think I was able to have video in this presentation. This is actually a presentation. Very much condensed, but we have waves of some pretty, relatively rough waves that you can see the backside of it. It really does. It's pretty good.
Cool. Right on. Appreciate it.
I'd like to thank our speakers for